Hey, pre-algebra class, welcome to the last section of this unit, 11.1, Language of Geometry. Today's objective is to define and identify basic geometric ideas. Here we go. First off, some vocabulary. Today is very vocabulary heavy, and then recognizing that vocabulary and identifying it. A point is a specific location in space with no size or shape. So you've probably seen on a graph before, just a point, and usually has a name like point A or maybe point P, something like that. So we do need to identify points with a letter, and you'll see many points today. A line is a collection of points that extend indefinitely, that means like forever, in two directions. So lines are infinite. They do not stop, they do not end, they go on forever, there and there. And we need to also name lines. There's a few different ways we can name them. I'll call this line A, B. And the way we would write AB is A, B, with a little mini line over top of it, like a hat almost. So if you see this, line AB, I'm referring to this line. Now, where does line A start and where does it end? Trick question. It does not start, it does not end. It's infinite, right? So this is a line that passes through point A and point B. Now, if I put another point on here, let's say I had point C on here as well. When I write AB like this, we're still referring to the same line. I could also name this line, line AC. Okay, line AC is the line that passes through point A and point C. Notice that is exactly the same line as AB. So these are two different names for the same line. Can you think of a third name for this line? There is one. It is line BC. So AB, AC, and BC, these are all names for this line. It's a collection of points. How many points are on here? There's an infinite number of points. Now, we've only got names for 3 of them, but I could put many more points on this line. There's no limit to how many points are on this line. Because remember, a point is a specific location in space with no size or shape. And with this line being infinite, I could put an infinite number of points on that line. Now, you wouldn't really do that, but it is possible. There's an infinite number of points on that line. A line segment is a part of, let me correct this a little bit. So a line segment is a part of a line containing two endpoints and all the points between the endpoints. So looking up at our figure above, we have point A, and let me get rid of those points that I added in there. I'll just make point A, B, and C bigger. So there's point A, there's point B, there's point C. So there's a few line segments here that we can use with A, B, and C. There is line segment AC. Now notice when I name a line segment, I have a little mini line segment over the top of it. Line segment AC starts at A, ends at C, or you could say starts at C, ends at A, either way, but it has definite endpoints, and A and C are called the endpoints. So when you name a line segment, it has to be named by its endpoints. So AC is that segment right there. My mouse is covering, my cursor is covering line segment AC. There's a couple more on here as well. Line segment BC. Line segment BC has endpoints at B and C, so line segment BC visually appears to be shorter than line segment AC. Can you name a third line segment? Line segment AB. You do have to include the little mini line segment over top of it like that. All right, there you go. So that's points, lines, and line segments. Moving on. Let's talk about a ray. Ray is a portion of a line that extends from one point infinitely in one direction. So I'm going to draw that same line, line A, B, C. All right, so let me get that drawn there, A, B, C. Okay, So that's a line. You could call it line AC, line AB, line BC, whatever. But there's a few rays on this as well. One is ray AC. Now we always name a ray using the endpoint first. This has an endpoint at A, and it goes on forever through C. And we put, what do you think we put over top of this? A little mini ray, like that. Okay. There's another one on here. There's ray B, C. Okay. There's a couple more. See if you can name a couple more. There's ray CB. So ray CB has an endpoint at C and passes through A. Again, an endpoint at C and it passes through A forever. That's why it's got the arrow on the end. That means it goes on forever. And then finally, ray BA. There we go. Are any of these rays the same? We talked about how the lines were the same line, even though they had different names. We talked about how the line segments were different. Are these the same or are they different? Like, is AC the same as BC? The answer is no. But there is one, we could name AC something else. So AC has a different name. We could call it AB. These two are the same. Why are they the same? They both have an endpoint at A, and they go on forever in this direction to the right here. This one passes through B, and AC passes through C. They both are the same. They both pass through B. How about BC? Could we give BC a different name? No, not with the given information we have here. So starting at B, going to the right, we only pass through C. How about CB? Could we give CB a different name? Pause the video now, see if you can get this. Could we give ray CB a different name? Well, an endpoint at C passing through B also passes through A. So we could call this ray CA as well. How about ray BA? Could we give ray BA a different name? An endpoint at B going forever through A. No, we have no other points, so we can't give that a different name. Let me go back to the line segments for a moment. Line segment AC, that has an endpoint at A and an endpoint at C. That's the same as if I called it line segment CA. These two are the same. How about BC? Could I have a different name for BC? Well, endpoint at B, endpoint at C, you could call it CB. These two are the same line segment. And AB is the same thing as BA. Those two are the same. Pause the video now. Name 2 points, a line, 2 rays, and a line segment in the figure. Pause the video here and try this out. All right, so for the points, you could have said M, L, V, P, or N. 2 of those 5. I'll take just the letter. That's fine. You could write just the letter M. Or if you wanted to, you could write point M, whatever. Either of those will work. But that would count as 1, right? Because either it's point M or point M, one of these two, but you need to choose 2 of these 5. So you could have had M and L, M and V, M and P, M and N. You might have had L and V, L and P, L and N, whatever. Just 2 of these 5 and you're good. How about a line? There's a number of lines here. You might have said line MN. You might have said line MP. You might have said line VP. You might have said line LN. Any 2 of these letters, and that is the name of that line. Now, take a look at this. LV. Line LV. Is that the same line as line VN? The answer is yes, that is the same line. Both of these lines pass through L. Both of these lines pass through V. Both of these lines pass through N. Another one I could do, line MP. All right, these are all the same line. That's why we only had you name one line, because no matter what you picked, it's the same line. 2 rays. All right, again, there's a lot of rays here. Let's talk about the rays you could have used with the endpoint M. ML is the same ray as MV, is the same ray as MP, is the same ray as MN. Let's talk about P. Let's say you had P as an endpoint. Well, if P was an endpoint, you could add PV, which is the same ray as PL, which is the same ray as PM. All of those rays are the same. Now there's another ray with P as an endpoint, PN. That is different from the other three. PV, PL, PM, they all go off in this direction to the left, and PN goes off in that direction to the right. All right, a line segment. Again, there's a number of line segments you could have chosen. ML is fine. LV is fine. VN is a line segment. Choose any two of these letters, and that would be a line segment. Now, what you shouldn't have done is this. Let's say you had LP as a line segment. That would have been fine. But then if you said PL, that's not a good enough choice for two line segments. Why? That's the same line segment. So that is just naming one line segment. So you might have said LP and, I don't know, LN. Or you might have said VM, whatever. All of these are okay. VM. All of these are different line segments. There you go. A lot going on here. I know it looks like there's not much happening. There's actually a lot happening here. How about this one? Name two lines. Where do they intersect? Choose any two lines. Tell me where they intersect. Pause the video now. Try this one out. Okay. Let's talk about this vertical line here. You could have called this AC. You could have called this CF. You could have called this CH. You could have called this FH. Just any two of these letters. So I'll choose I'll call it AH, line AH. And I'll name another line. How about this one here? I can call that one BD. What's another name you could have called that one? You could have called it BC. You could have called it CD. Any of those. Where do these two intersect? They intersect at point C. Okay. Now, if you chose line BD and line EG, these don't intersect. So that would have been two lines. Yes, you chose that correctly, but they don't intersect, so that's no good. If you did choose line AF and line FG, they intersect at point F here. So as long as you're choosing this vertical line and either one of these two, they either intersect at C if you chose the vertical line and BD, or they intersect at F if you chose the vertical line and EG. Let's talk about some vocabulary. An angle. When two rays have the same endpoint, they form an angle. Angles have the following: a vertex, sides, which are rays of the angle, a degree, which is the unit of measurement here. We're not going to talk about that today. Protractors are used to measure angles. Let's talk about the types of angles. We have acute angles, which are greater than 0 degrees but less than 90 degrees. We have right angles, which are exactly 90 degrees. Obtuse angles, which are greater than 90 degrees but less than 180. And straight angles are exactly 180 degrees. All right, we can name angles as well. So here we have an angle. It's all about the vertex. Notice how many angles are occurring at this vertex? Only one. So we could call this angle M. Compare that to this figure here. This figure has a vertex at V, but there's more than one angle happening at V. So that's a different case. We'll get to that in just a moment. So we could call this angle M, or we could use the three-letter method. And the three-letter method uses the following. The vertex always goes in the middle, M. And then we could put the other two letters on either side, N, L. So this is angle NML. Notice the vertex always goes in the middle. Or you could call it angle what? LMN. Remember, the vertex always goes in the middle. Angle LMN. All three of these are the same angle. We can and all of them are okay to name them. Like there's not one name here that's more correct than the other. It's just a different way to name this angle. Now that's not the case here. Here we have more than one angle happening at vertex V. So take a look at angle 3. Come up with a name for angle 3. Pause the video now and do that. Angle 3, we could have called it angle DVE. Or you could have called it angle EVD. Either way, V has to be in the middle. All right, pause the video now and name angle 4. You could have called angle 4, angle EVF. Notice V is in the middle, your vertex, or angle FVE. FVE. So that vertex is the point where the two rays come together. There's a third angle here. So this is one angle, and we can name it either way. This is a second angle. We can name it either way. What is the name of the third angle? Don't just call it angle V. Pause the video now. Come up with the name of the third angle. Angle D, V, F. Or you might have called it angle F, V, D. So there's your third angle happening there. I call it the combo angle. It's these two angles together form that combo angle. More vocabulary. A plane is a flat surface with no edges or boundaries. So imagine a tabletop that goes on forever in every direction. That is a plane. All right, 3 points must not lie in the same plane. 3 points must not lie in the same plane. Lines, intersecting lines. 2 lines that intersect at a point. We already talked about intersecting lines earlier today. Parallel lines, there is no point of intersection. So we talked about parallel lines earlier as well. Perpendicular lines are 2 lines that intersect to form a right angle. So parallel lines would look something like this, right? Or then maybe something like this. So lines that go on forever and do not intersect. Perpendicular lines, they do intersect and they form a right angle. So these 2 lines, if I tell you that this is a right angle here, these would be perpendicular lines. Skew lines are 2 lines that do not intersect or lie in the same plane. You'll see that example in just a moment here. All right, so let's first talk about skew lines. This is like a box, like a Kleenex box maybe. Take a look at BC. Take a look at GF. They do not touch, they do not intersect if they go on forever, but these are on different planes, right? So BC is in this plane here on the front side of this box, and GF is in the plane on the back side of the box. And not only that, GF is in the plane on the top as well. So find examples of parallel, perpendicular, intersecting, and skew lines. So I just gave you an example of a skew line, BC and GF. There's more, so you can come up with them on your own. Pause the video now if you haven't done so already. All right, so parallel lines, there's a lot here. I'm just going to give you one pair, EC and FD. That's one pair. I'll give you another pair here. How about HD and BC? For lines to be parallel, they must be in the same plane, meaning the face of the box. You touch the face of that box, right? Perpendicular lines, well, I'll give you one example. Again, there's a lot here. AB and BC, they are perpendicular lines. I'll give you another pair, FD and HD, or maybe CD and HD. Any of these are perpendicular lines. Intersecting lines, just choose any pair that intersect. The perpendicular lines intersect, so any of those would work as well. And we already talked about skew lines. All right, that's all. Thank you very much for your time and attention. Good luck on the worksheet.